Good evening, guys. Good evening to everyone. I hope everyone is in the session. I'll just wait for another 2 more minutes, okay? And we'll start the session. Okay, I see this is the strength. Fine. Yeah, good evening, guys. So I see a query. Please upload recorded lecture of the session. Yeah, I'll inform the operations team. Don't worry about that. Yeah, good evening, Shivam. So, what are we going to study today? Okay, Akshay. So Akshay, where did we left? I mean, what was our last topic? Guys, what was our last topic? I see supervised and unsupervised. Can I see also a query from Shiva saying, so Shiva, they need to make sure that they have registered with the mail ID, and please make sure that they were monitoring the same mail ID and also check the spam folders and all. Okay. I'll just inform the team actually. Yeah, we are discussing about the machine learning life cycle. Correct. So what are we discussing, Akash? We were discussing about the label encoding, right? So did you understand what exactly the label encoding is? Any doubts in understanding the label encoding? In the last session, we have covered all these topics. The statistical test, starting from Z-test, F-test, ANOVA, and also chi-square. Then we have started with the machine learning life cycle. Correct. So in the machine learning life cycle, these are all the steps involved. And we have started with the types of machine learning: supervised machine learning, unsupervised, and also reinforcement learning. So in the supervised, it learns on the labeled data and predict on the unseen data, and it has regression and classification. And also when the target column is numerical, it is a regression, and when it is a categorical, it is a classification problem. And here we also have an independent features and the dependent features also. Dependent feature is nothing but the target column, and there is this example of brand of an ice cream, and then we have this unsupervised learning. Unsupervised learning deals with unlabeled data. So moving forward, we have this reinforcement learning, which works on the reward based system. Then we have gone through this exploratory data analysis, which is completely related to exploring the features, like in three different ways. There is this univariate, bivariate, and also multivariate we see. Univariate is single column features, bivariate is two column, and multivariate is three or more than three columns. And also box plot. Box plot, I have explained you what is an outlier, but we haven't visualized this particular box plot. We'll visualize it, okay? And then we started with the machine learning life cycle, defining the problem statement, like based on the domain, type of the data, data gathering, data collection, data pre-processing. And in the data pre-processing, we're having like how to read the data, what are the initial 5 major steps that we need to follow in order to make sure we are reading our data: info, shape, describe, null values, duplicates. So these are all the good practices in order to make sure we are going through our data. And then we perform the exploratory data analysis to find the insights from each and every column, and also to find the outliers also. Then we'll make sure that the data is normally distributed, okay? And then we'll go for the feature engineering if any feature engineering is required. And also in between, if any irrelevant columns which are occurring, I mean, we feel like if that particular column is irrelevant, then we'll drop those columns also. So one of the irrelevant column example I can give is serial number. Okay, serial number is not required, correct? And if you see here, label encoding, correct? So now today we'll be discussing about this: scaling the data, correlation, model selection, split the data, building and training the model, evaluating the model, test the model. And up to splitting the data we'll be discussing today, because you need to understand how the machine learning models work, right? So after splitting the data we'll discuss, and if still the time permits, then I'll start with the linear regression model, okay? Okay, and regarding these handouts, I will be uploading, okay? This particular previous session handout has not been yet uploaded. I will upload this handout, okay? Don't worry. Okay, fine. So anyone, any more doubts? Okay, so machine learning life cycle. Fine. Yeah, recording and also, yeah, recordings. See, see watches, the recording related to recordings, the thing is, in the Telegram group, you will be getting access to that particular link, right? So can you please provide the, yeah, I will be providing the drive link. So please make sure you mention once again at the end of the session, okay? Yeah, attendance is mandatory. I think this is the third time, I guess, I'm repeating about the attendance, correct? Fine. So we'll start with the session. Please keep your queries. Okay, so now we'll be discussing about this null values, duplicates, okay? Null values, duplicates, and then we'll go for this feature engineering once again and label encoding, okay? Then we'll start with the workflow again. I'll discuss about the null values and duplicates. So to discuss about this null values and duplicates, let me just draw the data set, okay? Just create the data set or else. I'll do one thing, I'll share my collab notebook. Okay? Okay, let me just share my collab screen. Okay, I think yeah, the session is also connected. Fine. So this is our collab notebook, right? So initially we'll start by importing the dataset. Okay, we'll start by importing the dataset. Now in the C1 library also we'll have datasets. Okay, in the C1 libraries also we'll have this dataset. So let me just import C1. Import C1 as SNS. Okay, we'll import it. Okay. So in the SNS we'll have datasets. So let me just check SNS dot. Will be under load parameter, I guess. Just a moment. First, get datasets. Okay. SNS dot get datasets. And here, if you want to mention, we can. So let me just load the names. So these are all the datasets present. Okay. These are all the datasets present, which is related to anagrams, Anscombe, attention, brain networks, car crashes, diamonds, dots, Dow Jones, exercise, flights, Giza, Glow. So these are all the Titanic, tips, taxis, Iris. So we'll consider this Iris. Okay, we'll consider this Iris. So let me just load it as df dot sns dot load dataset. Instead of planets, I'll just pick Iris. Okay, I'll pick Iris. And let me just load the dataset. Okay. Okay. So now what I did first initially, I have imported this library name C1 from the C1 is what? C1 is nothing but a visualization library. And I'm keeping an alias as SNS as we'll be continuing, right? As we'll be doing the same, right? So in the C1, we'll have few of the data sets, okay? So these are all the data sets list. These are all the data sets list. But I just want to use only Iris data set. So I have loaded the data set from the C1. Now I need to understand initially what are all the steps as per the machine learning. I need to understand the domain and I also need to have the data collected. But I'm already having the data. So now I will understand the domain. Okay. I'll understand this domain. So here it is saying about sepal length, sepal width, petal width, species Setosa and Virginica. Correct. I'm as of now, I'm saying all this, right? I'm saying only these. So what I will be doing is first initially I'll just type Setosa and I'll check. I'll type Setosa, take a new tab, and Setosa and enter. So we'll look into the images. Okay. So here I think you can see, right, everything clearly in this image. I think this image is visible to you. Visible, right, image? Okay, thank you. So these are the petals and these are the sepals. Okay. Petals and sepals. See, the flower is in this format. I mean, the leaf is in this format. So it's a petal, and if it is in this format, it's a sepal. So each petal and sepal will have a length and also its what it will have? It will have length and also its width, right? So now this versicolor, virginica, and also setosa are three different flowers. Okay, three different flowers. Now each flower is having their own sepal and their own petal. Okay, each flower they were having. So now the domain is related to some flower, right? And what are the different types of flowers we are seeing? Setosa, versicolor, and virginica. And each flower is having what? Sepal length, sepal width, petal length, and petal width. Correct. So what is a sepal and what is a petal? Here it's clear. The petal looks in this format and the sepal looks in this format. Correct. So now we understood. So that particular data is related to this sepal length and sepal width. And based on that sepal length and sepal width, we are saying that it is belonging to versicolor, it is belonging to setosa, and it is belonging to virginica. Correct. So that is what this data set is, right? So for the sepal length 5.1, okay, for the sepal length 5.1 and sepal width 3.5, where it is having a petal length of 1.4 and 0.2, then in that case it is belonging to setosa. Okay, in that case it is belonging to setosa, it is saying. Okay, fine, got it. So how it is for virginica? Sepal length is 6.7, sepal width is 3, petal length is 5.2, and petal width is 2.3. So if it is following this kind of pattern, then it belongs to virginica. Correct. So this is how we will understand the data. But one more thing. Here I am seeing only two values, setosa and virginica. But if you see here, in this image, we are having setosa and virginica, and versicolor also we are having. Okay, let's see. Now let's see that in our data set, are we having a versicolor or not? We'll see it. Fine. So what is the first major step initially that we need to do after importing the data? We need to check the information, right? Dev.info. Okay, it is saying that total index range is up to 150. So there are 150 entries, and the range is from 0 to 149, where the data column has total 5 columns: sepal length, sepal width, petal length, petal width, species. So here we are having 5 columns where each column will have its length, the sepal's length, sepal width, petal length, and petal width, then followed by the species. Okay. And if you see, there is this non-null count also. So non-null count means not a null value. So how many not null values we are having? 150. So how many rows we are having? 150 values, 150 rows. And also we are having 150 not null values. So that means no null values are present. And you can see the D type. D type is data type, right? So what it is saying? All the sepal and the petal length and width are of float 64, and only species is object. Species is object. So what does object data type represent? What kind of data it has? What kind of data does a object represent? Yes, correct. Textual data. Fine. So now we're done with the info. We're done with the info. So what are the other things that we can do? What are the other things that we can do? After doing df.info, I can do check the shape also, right? Actually, I need to do this first, but okay. 150 rows, 5 columns. And remember, whenever you are working on Google Colab or else Jupyter Notebook, comments are the first major important thing, okay? Rows and columns. Comments are the very first major important thing. Okay. checking the information of the data types or checking the info of the data. Checking info of the data. Loading the iris dataset. From C1 loading the doing over here. From C1 loading the datasets. It's loading the names of the dataset. Okay. Libraries, importing the libraries. So what kind of comment we can add? We can add libraries. Okay. So now comments are very important. Okay. So after doing the shape also, what we need to do? One more thing is we can do the describe, right? Describe. Okay. So count. So what is describe doing here? What is describe doing over here? It is considering only the numerical values. Correct. It is considering only the numerical values, and it is calculating the count, the mean, the standard deviation, how it is, how the points are being deviated, the minimum, the 25th percentage, 50th percentage value, or the 75 percentage of the values where they are lying, the maximum value. Okay. Then now, so after this, what I need to do? What are the other two major important steps I need to check? What are the other two major important steps that I need to check, guys? You forgot? Remember null values and what was the other one? Duplicates, correct. So first we'll check the null values. So how to check the null value? What is the syntax? Def dot is null method and also sum the method. Sum method, correct. So what it is saying? So sepal length is having zero null values. Sepal width is having zero. Petal length is having zero. Petal width is having zero. And even species is also having zero null values. Fine. So there were no null values present. Okay. So duplicates, right? So let's check the duplicates also. Let's run this. So now what it is saying in the NumPy integer 64, fine. It is saying that there is one duplicate value. See, you can see the one, right? So it is saying that one duplicate value which is present in the data frame. Okay, one duplicate value which is present in the data frame. So we need to drop the duplicate value. Okay, we need to drop the duplicate value. So now what I will be doing is def dot drop duplicates, drop duplicates. Okay, drop duplicates. Fine. Okay, now I am having only 0 to 149 rows only I am having. So in that case, what should happen in that case? Okay, I think I'm making complex. Understood until here? Understood until here? I don't see any reactions also. Okay. One row has been dropped. One row has been dropped. Why that row has been dropped? So similarly, a row is present to that. Okay. Similarly, a row is present exactly. So duplicates are present. So duplicates values have been dropped. Okay. Fine. Now, after we have dropped this particular duplicates, okay, it is saying that 149 rows now. So one row has been dropped. Correct. So let me just check the shape again once. Why it is giving me 150? It is giving me 150, right? What is the shape it should return? What shape it should return? What is the shape it should return, guys? Yes, correct. 149 it should return. But why it is giving 150? This operation has been executed. Correct. But here also it is showing 149, but it is not reflecting in the data frame again. It is not reflecting in the data frame again. Let me just assign a variable over here, okay? See, this is important again. So now what I will be doing, I will just assign a variable and I will check a dot shape and I'll rerun this, okay? Okay, again, if I check the duplicates also, it is saying that I'm having one. See, I'll just show you the difference, okay? I'll just show you the difference. Let me just run it from the very first. Okay, fine. From the first, let me run it, okay? So duplicated, I'm checking one duplicate value, drop the duplicate, so 149 I got. So df dot shape, again 150 I'm getting, so there is some error. Okay, so let me just check if that value is still present. Okay, that value is still present. So let me do this. I'll assign a variable and I'll check the shape of that variable. Okay, I'm getting 149. So is it reflecting in the data frame? I'll check, okay? Is it reflecting in the data frame? Let me check, okay? It will not reflect. It will not reflect. Again, I'm still having the one in this data frame. But here for A, it has reflected. Why? Because I told in the data frame, I want to drop the duplicates. Then I have assigned a variable. So in this particular variable only this particular operation will be performed, okay? This operation will be performed and assigned, all the remaining values will be assigned to this variable only. And this will not reflect in the whole data frame. Again, if I check, I'm having one null value. I mean one duplicate value, sorry. So in order to reflect those things in the data frame, all I need to do is df.drop duplicates, and here I need to write in place equals to true. Okay, in place equals to true, and let's run this and check the shape again. So if you see, the duplicates have been dropped and also the shape has been reflected. Correct. The shape was reflected and the duplicates have been dropped. So understood why in place is true used. Understood why in place is necessary. Fine. Hope you people all know why exactly in place is used. And there is another important component also over here. So which I told you duplicates, right? So duplicates means same value repeating twice, right? Same value repeating twice. Same value repeating twice. So here I can choose which row to drop first, okay? Same row values repeating more than once, okay? Same row value repeating more than once, duplicates, correct? So now what? In order to make sure, now let's say I will consider only the first value. Okay, let's say I'm having the duplicate values in first row, third row, fourth row, and fifth row. Okay, duplicates I'm having in first row, third row, fourth row, and fifth row. Okay, so if I just mention as first, okay, keep equals to first. If I mention, the first row value will be preserved and all these rows will be dropped. Okay, all the other rows will be dropped. And if I mention last, okay, if I mention last, the last row will be preserved and other remaining rows will be deleted or dropped. Okay, so let me just do that. Keep equals to first. Okay, keep equals to first, but it should throw an error now. Okay, it is working fine. As I have already implemented, I thought I will get an error, but it is working. So it has kept the first values and it has dropped the remaining values. Okay, first means keep last also we are having. Last means keep the last value, keep the last row of the duplicate and drop the other values. Okay, so this is the difference for the keep first and keep last. So fine, now I got this 149 values. I just want to check now. Okay, I'm having, so if I'm having 149 rows, what should be the index here? See, I'm having 149 rows. What should be the index for the last row? It should be 148, right? Correct. It should be 148. So now all I can do is I need to reset the index, correct? Okay. I need to reset the index. So to reset that, what I will be doing is df dot reset index, and also one more thing in place is true. Okay. Let me just run this. Now 148 is reflected. Got it? Now the 148 is reflected. Okay. Understood why in place is being used? To reflect the things, to reflect whatever the operation in plus equals to true is nothing but to reflect whatever the operation that you are performing in your file in the whole data frame. Okay. Let me, yeah, here we are using in place, right? Let me just write here. Yeah. Fine. Okay, I have lost another asterisk. In plus equals to true. What exactly it is? It means that whatever the operation which is performed in that particular method which we are calling, okay, whatever the operation performed in the method we are calling, reflect the same in the data set. Okay, reflect the same in the data set. This is why we use in plus equals to true. Okay, this is why we use in plus equals to true. If I'm not using in plus equals to true, again if I check the df shape, it will be one. Sorry, it will be 150 only. Okay, as I have used in plus equals to true, then I got this 149 values. If not, it will show 150 only. It will show 150 values. It will not drop the duplicate from the data set. It will drop the duplicates from only that particular assigned variable, that is a. Okay. Fine. So reset index, fine. So understood until resetting the index. Understood until reset index. Everyone. And any doubts? please ask in the Q&A. I see few queries. Where did I miss? Okay. Yeah, to change in the original dataset. Can't we use a.duplicate.sum? Okay, if we use a.duplicate.sum, it will show 149 only. But I will not be performing all the operations on A, right? I have defined my dataset in the variable df, right? I have assigned all the dataset values to df. And next time, if I want to perform any other operation also, I will use df only. Why would I use a? Correct. If I assign the variable as a, then I may perform all the things on a. Then what is the use of in plus equals to true over there if you are performing all the operations through a dot duplicate? Understood. Okay, see why we used again in plus equals to true once we checked for duplicates. See, okay, this was related to fine. So once we check the duplicates, what was the answer? We got the same value. I mean, again we are having the duplicate value. Whatever the operation we have done, like dropping the duplicate, the operation have not been performed on the entire data set. It has been performed only in that particular variable A. So to make sure that it has been, the operation is being also reflected in the whole data frame, we have used that, okay, in plus equals to. Yeah, the notebook will be shared. Df dot duplicated though. So now df dot duplicated the dot sum. So what exactly it is doing is it is finding how many duplicate values which are present in the whole data set and it is summing them. Summing them in a sense, it is giving the count, how many false values or else how many values we are having, it will give the sum. So without adding the sum, if we check, we can see the true false boolean table, okay? I think in place I have explained. Only simply use, I think Saho I have explained this. Okay. This means if you're not using input equals to true, then the operation is performed on the duplicate dataset. Not clear, but I'll try to answer this. Your question is not clear. So this means if we are not using in place equals to true, then the operation is performed on the duplicate dataset. See, if we are not using in plus equals to true, whatever the operation that we are performing, it will not be reflected. It will be reflected to that particular cell only. If you are assigning a variable, like for example, here we have assigned the variable as a, right? So, and I didn't mention in place equals to true here. So if I just call the a again, let's see, let's see, a dot shape again, if I call, it will again give me the same shape. And what's happening here? It is reflecting only in this variable. Okay, it is reflecting only in the variable. It is not reflecting in the whole data frame. If you see here in the whole data frame, again, I'm having the duplicate value. If I do a dot duplicate, I won't be getting anything. Just see. See, if I do a dot duplicate, I got 0. But data frame, again, I'm having the 1. Again, I'm having 1. It is not reflecting in the data frame. I want things to be reflected in the data frame. Correct. I want the particular operation which I am performing or the method which I am calling needs to be reflected in the data frame also because I am performing operations on the data frame level. Correct. Performing operations on the data frame level. So that is the reason I have used in plus equals to true for dropping the duplicates. Okay. You're not assigning the duplicates. If you're not assigning, nothing. I mean, like it will only reflect in that particular cell and everything will be the same. Okay. If you're not assigning that variable also, everything will be same. Updated will not, if you assign a variable only, the updated data will be stored. If you're not assigning any variables, then it will be up to that particular data, a particular cell only. If you run that cell only, then you'll be able to see the data set. That's it. And in other cells, it will not be reflected. and keep first. So duplicate values, I told you, right? Duplicate means same row values repeating more than once, right? And here in the dropping duplicates, we have two parameters, first and last. First means keep the first row of the duplicates and drop the other values. That means that duplicates means same value, right? So here it's same rows you can consider. So let's say I'm having two duplicate, like one duplicate, and the values which I'm having in the third row are the same values which I'm having in the fifth row. Okay. Now, if I tell keep equals to first, the third row will be staying as it is, and the fifth row will be dropped. Because if I'm having only one duplicate, if I drop that one single duplicate, I will have all the other different values, correct? So if I keep third row, if I keep like keep equals to first, the third row will be preserved and fifth row will be dropped. And if I keep equals to last, fifth row will be preserved and third row will be dropped. That's it. Yes, first value will be saved, others will be removed. I mean the first time repeating values, yeah, the first value. Correct. Okay. Any more doubts? Anyone know, right? So what is the next step in our machine learning operations? Reading the dataset we have done info, shape, describe, null values, duplicates, and we have also dropped the duplicates also. And exploratory data analysis, not right now, we'll do, okay? We'll do, but not right now. And feature engineering, you all know what is feature engineering. We all know what is feature engineering, okay? So now, anyone, do you want an explanation of feature engineering or else do you want me to proceed? Okay, good question from Kshitij. So what will happen if we have multiple duplicates and we don't use or we don't use keep? So by default, it will be keep equals to first, okay? By default, it will be keep equals to first. Fine. Now, feature engineering. Feature engineering, fine. I'm sorry. Feature engineering. Anyone remember feature engineering? Anyone remember the feature engineering? Okay, one more concept, reset index, right? I forgot, yeah. Reset index. So after dropping the duplicates, I will have 149 values. But in the index range, how many values it was reflecting for me? It was reflecting, where was that? It was reflecting again 149. If you see, it is reflecting 149. Range in between 0 to 149. But here it is saying 149 rows. But I will have 150, right? See, excluding this 0, I'm having 149. If I include that 0, it will be 149 plus 1, correct? So 150 it should reflect. It is giving me 149. So to make sure the indexing is correct, I did reset index, okay? Reset index I did, and I just want to reflect that index in the whole data frame. So now 1 to 148 I'm having. 148 I'm having. So this extra 0 if I add, 149 it will be. So I got 149 rows. Understood? Okay. Okay, I'll explain feature engineering once again. Extracting those columns, those are needed for target value. Okay, feature engineering definition using fine. Okay, fine. Okay, got it. Just a moment. So, also one more thing. I have told you, right? df.head. What exactly df.head does? df.head will return the first 5 rows. Okay, 1, 2, 3, 4, and the fifth. Correct. First 5 rows. And also similarly, we are having df.tail last 5. So 148, 7, 6, 5, 4, 4 to 8. So last 5 rows I'm having. If I just mention 10, it will also return last 10 rows. Okay, it will return 10 rows. Fine. So feature engineering. Okay, in feature engineering, I told you two examples, right? One is like combining the columns, and the other one is dividing the columns using the datetime index, right? I'll just explain that. But here in this particular data set, we can't perform any feature engineering. Okay, all the columns are important because okay, and other extra index column has been created. So we'll just drop this index. Okay, we'll drop the index. Okay, we'll just drop the index here itself. df dot drop index axis equals to 1 n plus equals to 2, and yeah. So now I got 148. Correct. Okay. So I will explain this syntax. Okay, I'll explain the syntax. Don't worry. I'll explain this. But before moving into that, feature engineering. What is feature engineering exactly? So either we can get the insights from the particular column, or else we can consider what are all the columns which are contributing for the model development. Okay, what are all the columns contributing for the model development? We'll be considering those columns. Now, if you see, each and every column is contributing for the model development. So each and every column is important. Correct. Each and every column is important. Sepal length, sepal width, petal length, and petal width are very important. And based on those values only, I'm getting the species. So those values are important. And previously the index is not important. So I have dropped that particular index. Correct. So now we'll discuss about this. Feature engineering is not required over here. Fine. Label encoding. Yes, label encoding is required. Label encoding is required. Now, first I will explain this syntax, and then I'll explain the label encoding. Okay. So what are we doing over here? As this particular column index is not required, so I'm dropping that column. Okay. So remember ILOC and LOC to perform the column wise operations. What we'll be doing? We need to have the label. And what is the label here? Index. As this is the column, I just need to mention the axis also. For columns, the axis will be 1, and for rows, the axis will be 0. Okay, we need to mention the axis. Then only it will understand where to check. Okay, which axis to check and what column to drop. We are mentioning what column to drop and where to find that column, and we want to reflect that particular operation in the whole data frame. So we are mentioning everything. If I want to reflect that, I want to reflect that particular operation in the whole data frame. So I have mentioned index equals to true. So column name is index, axis is 1. Axis 1 is nothing but the column operations. Okay, we are doing the column operation. Axis 0 is the row level operations. So after running that, I got this as a data set. Now we have the label encoding also. We have the label encoding. So what does label encoding help us. Why label encoding is, I told you, right? Label encoding will help us to encode the categorical columns. I'll just write here. Categorical values or else the categorical columns. Convert to numerical. Okay, it helps us to encode the categorical column to convert to numerical. Categorical column in the sense, whatever the values which are present in the column, it will be converted into numerical. Converted to numerical. We'll see how the label encoding works. Okay. First, what we need to do, we need to import the label encoding. Okay. We need to import the label encoding, and that label encoding is present in the scikit-learn library. Scikit-learn is sklearn. Okay. So from sklearn dot, so it's a pre-processing step. So it will be present in the pre-processing. I am importing label encoder. Okay. So for this library, let me just assign a variable that is le is equals to label encoder. Okay, now the label encoder is stored in this particular variable le. Then what I need to do? I need to apply the label encoder on which column? On this particular species column. Correct. So now what I'll be doing is, so now label encoder has been defined. What I need to do? I need to write the column species is equals to le dot fit transform df dot species. Okay. So what is this syntax here? Label encoder, as I have stored it in the le, right? So label encoder fit transform what this particular column. So fit on this column, consider this column and transform this column as per the label encoding. Okay. And I want to store these values with, I want to store the transform the column values in the same column name. So I want to store the transformed column values in the same column name. Okay, so it will reflect again in the same column. Let's run this. Let's check the data frame now. So now if you see, the species is 0, 2, correct. Previously it was Virginica. So let me just show it in df.head format. So now all the values are 0. In that case, all the Setosa values are 0. All the Setosa are 0. But I just want to know how many values is Setosa having? How many values is Virginica having? Or else is there any other values which are involved? Okay. To do that, what I need to do is I need to do the value comments. Div dot df and followed by the column name dot value counts. So 0 is representing 50, 1 represents 50 rows, so 2 represents 49 rows. So this df dot species value counts even before applying the label encoder also we'll do once. Okay. Let me just run the cells once again. So I'm just running the cells once again to show you the difference. So what are the values here? 0, it is 50. What is 0? 0 is Setosa. Okay. And for versicolor, what is versicolor? It is 1. And for 49, it is 2. What is 49 here? 49 is Virginica. Okay. So all the 49 values which are representing Virginica are label encoded as 2. All the 50 values which are representing 0 and 1 are actually, those values are actually versicolor 50, setosa 50. Okay, setosa is 0, versicolor is 1. Because we're having the same number of 50 rows, right? Now we may get a question, right? Which 50 refers to which? So the first 50 refers to setosa, second 50 refers to versicolor. 0 and 1. Okay. So now if you're having doubts, post it in the Q&A. If anyone is having any doubts, let me know. I'll just stop the screen share until now in today's session. Okay, if no one is having any doubts, I think Ayush, you have understood, right, what label encoding is doing exactly? Ayush, Akash. Okay. So let's have a short break for 10 minutes, okay? Let's have a short break. And I see a few other queries also. I will address all the queries after the break, okay? Let's have a short break for now. Thank you. Okay, I see. Savita, are you new to the session? We're actually on the break, okay? We are having a short break, which will be completed in another 2 to 3 minutes. Okay, please have a short break, and the session is from 6 to 8. Okay, don't leave. Okay, so I hope everyone is back from the break. Just a moment. Okay, fine. So I see a few queries. The project structure cover image. Okay, fine. And other queries. So once the sessions are over, training sessions are over, you will be receiving the projects links. Okay. Yeah, I'll be sharing this file also. Okay. Okay, notepad, fine. You're also on the notepad session, fine. I'll share that. Okay, don't worry. I'll share the notebook. Okay, don't worry. I'm doing it in Colab. Okay, Colab, Google Colab. So feature engineering, everyone understood? Feature engineering, everyone understood? Okay, fine. If anyone is still having doubts in understanding the feature engineering, let me know. So now we'll discuss this label encoding. If you people are having doubts. So what are all the flowers? The domain is flowers, right? We write it properly. The domain is flowers. Fine. So in these flowers, what are all the columns we are having? We are having sepal length, we are having sepal length, sepal width, or else let me just write it as sepal width. The first column, second column, and what are the other three columns? Petal length and petal width, and also species. So these are all the five columns, correct? These are all the five columns which I'm having. Okay. Now, so this column is a numerical column, and even this column is a numerical column. This is a numerical, and this one is a categorical. So even this is a numerical, this one is a categorical. Categorical is textual column. Textual column. So what values are we having in this species? We're having setosa, setosa. We're having virginica, and also we're having versicolor, right? Versicolor, right? So we're having three values in species, where setosa is having 50, and what are the other columns? Which value is having less? Virginica is having 49, right? So for virginica it is 49. For versicolor it is 50 again. So in the total 149 rows, total 149 rows, 50 setosa, 50 versicolor, and 49 virginica. Okay. So now what happens is in label encoding. So what are the labels here? Setosa, virginica, and versicolor. For which column species? Correct. So now setosa is considered as 0. Versicolor is considered as 1. Virginica is considered as 2. Okay. So in the column, in the species column, I'm having what values? Under the species column, I'm having setosa, versicolor, virginica, right? So for this column, if I do label encoding, so how I'm having the values? So same column name again, but setosa it will be 0, versicolor it will be 1, virginica it will be 2. That's it. This is what the label encoding is. This is what the label encoding is. Understood? Understood? Understood label encoding. All those 50 values for setosa, which all those 50 values for setosa, it will be setosa. So that will be encoded into 0. That will be encoded into 0. That's it. Okay. Fine. So let me just share the collapse screen. I hope you are able to see the screen. Fine. Okay. So let me just share the full screen. It will be better. Yeah, thank you. So this is the notebook we are working, and here we are at the scaling the data. So in order to scale the data, we are having two different types of scaling. Okay. Two different scales we are having. What are those two different types of scales? Standard scaler and the min-max scaler. Okay. Standard and min-max. Just right here. Standard min-max scaler. Okay. So these are the two different types of scalars which I'm having. Actually, there should be no space. Two different types of scalings we are having, standard and min-max. So what exactly standard scaler and what exactly min-max scaler and why scaling? Okay. When to use what? We'll discuss. Okay. We'll discuss. Opening one note. Now the topic is scaling, right? The topic is scaling. Why exactly do we need to scale? Okay. Why exactly do we need to scale and why it is necessary? Okay. We'll see now. So let's say I'm having the column values. Okay, let's consider any column like what which column will be very suitable. Okay, I'll just consider two different columns. One column is age. Okay, one column is age, and another column we can consider is okay. Let's consider revenue or budget. Let's consider budget. Revenue we can't consider. Just a minute. So let me just consider the column X. Okay, column X, a random column X. Okay, random column X. So these are two different columns in two different data sets, or else in one single data set. These are the two different columns. Okay. So if you see the age column, the how the values will be, it will be from 2, 3, 10, 12, 20, 60. So I'll be having this kind of column. Okay, for this kind of column, scaling is not necessary because these are the actual values, correct? These are actual values and which will be in a certain range that is in between up to 0 to 80, or else if maximum it goes, it will go up to 90, 95, correct? Nowadays, the person most of the persons, or else most of the human beings, their age will be in between 0 to 95, correct? So it is having a range. So age column, on these kind of columns, scaling is not necessary. But what exactly scaling is? Scaling is nothing but bringing down all the values under one scale, okay? Will bring down all the values under one single scale. Bringing down all the values under one single scale to reduce the risk, okay? What risk? Risk of the numerical instability, okay? Scaling will prevent the numerical instability. And it is very important for the algorithms also, okay? It is very important for the algorithms also. And the scale data will also help us to easily interpret the data, okay? Easily interpret the data also, it will help us to do that. And one more thing, when to do scaling, and we can only do scaling on the numerical labels. So that is the reason after label encoding only we are discussing scaling, okay? Or else even at first also you can do the scaling. It's no issue, okay? There is no such rule that after label encoding only you need to do the scaling. You can also either do scaling first and you can do the label encoding, because scaling will be doing on only numerical part, numerical values, okay? So let's say there's a column X which is starting, the price column is better, okay? Let's consider price column. This column, and let's say the price is starting from 0, and now from 0 it is going up to 1C, okay? 1 crore. The values are going not exactly CR, but it will have like 0 0 0, okay? It will have all the zeros from 0 to 1 crore, all the values I'm having. So they're not under one single scale, correct? They're not under one single scale. I need to make sure that all the values are being brought to one single scale. I mean under one single scale, okay? Because 0 is somewhere at the start of this particular prediction, and 1 crore is somewhere over here, right? So these are not under the same scale. 0 and this 1C are not under the same scale, correct? So what I will be doing is I will be bringing them all these values under one single scale, okay? One single scale, and that scale is known as the standard scaler or min max scaler. What is standard and min max scaler? Now we will see, okay? What exactly the standard and min max scaler? Now we will see. So first we will be discussing about the standard scaler, okay? Standard scaler. Standard. What exactly standard scaler does? So it will rearrange all the values in this price column. This price column from 0 to 1 crore, it will rearrange all the values under one single scale, okay? It will arrange all the values under one single scale in the range -1 to 1, okay? -1 to 1, where this particular mean will be 0, standard deviation will be 1, okay? For the standard scaler, these are the metrics. The range is -1 to 1, mean is 0, standard deviation is 1. So it will, all the values from 0 to 1 crore will be in between -1 to 1, okay? Will be in between -1 to 1, where if I calculate the mean of all those values after bringing them to the scale, it will be mean 0, standard deviation is 1, okay? Standard deviation will be 1. And there is this min max scalar, okay? Min max. What exactly min max is? Min max is also will scale the data, but it will make sure that the range is in between 0 to 1, okay? Range is between 0 to 1. All the values will be in between 0 to 1. So how all the values in between 0 to 1, it will be, how all the values, it will be -1 to 1. So it will be like 0 0.004, 0 0.054, 0 0.694, 0 0.234, okay? And in -1 to 1, it will be -0.2, 0.4, 0.02, So the values will be in that particular format. So this is about the min-max scalar and the standard scalar. Okay, min-max and the standard scalar. And what is the main difference between the min-max and the standard scalar? See, the standard scalar will preserve the shape of the distribution. Okay, standard scalar will preserve the shape of the distribution. Remember, what is the main difference? You may get this question in interview also. Standard scalar will preserve the shape of the distribution, while min-max scalar will change the shape. Why it will change the shape? Because if you see, if you see over here, the range is -1 to 1, and here the range is 0 to 1. So even if I try to draw a plot as main is at 0, I'll get a shape. So it will be preserving the shape. But here in the 0 to 1, as it is starting from 0, and 0 and 1 value will be here. -1 and 0, it will be here. So it will be preserving the shape in standard. But in min-max, it will not preserve the shape. Okay. It will change the shape. Okay. It will change the shape in min-max. And also, it is to like it is said that the min-max can be sensitive to outliers. So min-max are very sensitive to outliers. When to use standard scalar and when to use min-max scalar. When we want to preserve the shape of the distribution, we can use the standard. And when we need to scale the data to a specific range, we can use the min-max scalar. To a specific range, then we'll use the min-max scalar. If we want to preserve the distribution, we go for standard scalar. Okay. It depends. It depends on the type of the problem that we're trying to solve and how we are using those numerical columns. Should scaling. Now, if you're having any doubts, mention. Okay, range -1 to 1, mean 0, standard deviation 1, it will be what? It will be standard scalar. Okay. It will be standard scalar. See, why scaling is needed means in one line, the columns which are having the long ranges or else the larger ranges will dominate the model. Okay. Will dominate the model and it will lead to poor performance. So once without scaling, you try to build a model and check, and with scaling, you try to build a model and check, you'll see a huge difference in the accuracy also. Okay. And it will also improve the interpretability. Okay. Easier to interpret the data. Hope you understood. Example for scaling. I just gave an example for scaling, right? Okay, fine. I got few queries. Let me just resolve those queries. I think others have understood. So let me just make sure that everyone is understanding. Fine. So by scaling, so when we're having in the large range values, okay, large range values, what happens? The model will not be able to interpret properly and it will not understand the patterns also. So we can't see much accurate models. Okay, much accurate models we can't be able to see. Now, if the same model, if the same data set which has been scaled, if that is being used, then we can see a huge difference in the accuracy. Okay, just a moment. We can see a huge difference in the accuracy. And coming into standard scalar and min-max scalar. So standard scalar means the values will be in between -1 to 1. -1 to 1 in the sense how? So it will be starting from -1. So minus 0.8, 0.8765, 87654. Okay, like that. all the values will be in between -1 to 1 only. Okay, -1 to 1 only. And in the min-max, it will be 0 to 1. And if I calculate the mean for this standard scalar, it will be 0. Because all the values are in between -1 to 1. So the mean will be 0. Okay. I hope it's clear. Still any confusion? Okay. So it is preserving the values in between -1 to 1 only. It is not closing them to start from 0. It is preserving from negative to positive range. So it will preserve the shape. Okay, it will preserve the shape. Now we'll see how exactly this is happening on the columns. Okay. Fine, scaling, right? So let me just add a comment over here. I think I need to share the window, right? Chrome tab is enough, I guess. Fine. Need to add what? Scaling. So in the scaling also, what are we having? Standard scalar and min-max scalar. The standard scalar and min-max scalar. When to use standard scalar and what does standard scalar do? It will keep all the values in between -1 to 1. And what are the other things it will perform? It will make sure the mean value is 0 and the standard deviation value will be 1. And a min-max scalar, what exactly happens? It will make sure the range of the values are in between 0 to 1. Okay, 0 to 1. And what is the main difference between these two? Main difference between these two, what it is? It will preserve the distribution. Okay, it will change. It will change. And min-max scale is also sensitive to outliers. Okay, so these are all the differences. Okay, these are all the differences. Let's see if the points are being applied. Okay, it is not applied. Fine. Let me just keep it here. Just keep it here. Fine. Okay. So now we'll perform the scaling. Okay, we'll perform the scaling on our dataset. But if you look at our dataset, what is the maximum and the minimum values? How to check the maximum and the minimum values? There are two different ways. Okay, there are two different ways. One is we can directly type df of consider any column petal length dot max. So the highest maximum value is 6.9. Correct. And similarly, if I do min, I will get minimum value. Correct. Minimum value is 1. So this is one way to check. What is the other way? Other way is df dot describe, right? Describe. In the describe, we'll be able to see this. Here, maximum. For what did we check petal length? petal length maximum was 6.9. Is it correct? Yes. Minimum is 1. Minimum 1 petal length. Petal length. Correct. So this is another way to check all the columns, minimum and the maximum value. So if you see all the values are in between 4.3 to 7.9 for sepal, 2 to 4.4 sepal width, petal length is from 1 to 6.9 and 0.1 to 2.5. So I see all these values are under normal, right? All these values are normal, like not in a long range, right? They were in between like a shorter range only. Right? They will fall under one single scale. So here scaling is not necessary, but if you want to do, we can implement. I'll show those steps. Okay. Run sklearn dot reprocessing import standard scalar. Okay. From sklearn preprocessing import the standard scalar. So how will work with this standard scalar? And we need to define the standard scalar as we can define it as scale equals to df dot, and we can apply. First we need to call that standard scalar and save that variable, right? Save it in the format of method. Fine. Now we need to do is scale dot quick transform. So if I just want to mention one single column, I can transform one single column, and if I want to mention all the columns, I can write directly df. I can write directly df, but that is not a good practice. So what I need to do now, I need to write each and every column, right? Each and every column I need to write. But instead of writing each and every column, what is the better way? What is the better way to do? The better way is to run a for loop, right? So I'll just write a for loop for this. So for again df dot columns, df dot columns. Now what I want to do, df of I, the df of I equals to scale dot fit transform. So now I want to do this. But one more thing. But the main thing is scaling is not at all necessary. Okay? Scaling is not at all necessary for this kind of data. And if you see here for species also, I got all the values. And if you see for the first describe, there is no species column. But now how did we get? Because now the species column has converted into numerical data. So for that also I got the describe. Okay, for that also I got the, where is that describe? Okay, fine. So let me just run this. You'll see the difference. Okay, let me just delete all this. Let me run this df. See the values. See the value range. See the range. Now df dot describe. So the range has been different. Let me just call the df only. Df I got it. Fine. See the values. Minus 0.09, minus 1.13. Okay, minus 1.01, minus 1.13. So for those values, it is trying to maintain the range. Okay, and we are using standard scalar. Standard scalar is what it does. It will write. It will preserve the distribution. Okay, it will preserve the distribution. Okay, see, we are having only 10 minutes. So this is it for the scaling part. Okay, this is it for the scaling part. So still we need to understand the correlation. But until scaling, everyone understood. Okay, I see another query also. So someone is asking, okay, why the minimum value is supposed to be -1? Okay, and then how come we are getting this -1? Okay, fine. Why negative value occurs? So it includes the main subtraction. Okay, it includes the main subtraction also. So like how standard scalar works is it works on a formula. Okay, it works on a formula. So the formula will be, it will be mu x minus mu by sigma. Okay, it will be x minus mu by sigma, where actually what happens is we'll be considering those values. Okay, let's say when x is equals to 1, we'll consider the main value over there. Okay, the main value we'll consider, and also we'll consider the standard deviation value of the whole values in the present in the column. So let's consider this is a sepal length, right? That is described. This is described. Right? So on this sepal length, I will consider the mean value and also the standard deviation value. Based on these two values, I will calculate. Okay? Based on these two values, for the first value, present in this sepal length is, let's say, 5.2. So I will calculate for 5.2. So whatever the value I am getting, I'll be considering that. So, but I'll try to maintain the distribution is being maintained, and I'll make sure that the mean value is 0 and the standard deviation is 1. Okay, it will be in -1 to 1, and that will be depending based on the mean and standard deviation. Clear? Doubt? Clear? I think it was confusing for you, if I'm not wrong. Okay, I'll just upload the collab file. Yeah, standard deviation 1, correct. So, and one more query you're asking, recording, right? Recording in raw. And also one more thing, I just forgot to share this. Just a minute. So everyone, I have shared a Google form link. Okay, I have shared a Google form link. So please, everyone, register in that. Okay, it is related to Google Generative AI. Okay, it is related to Google Generative AI. So everyone, do register in that. Okay? You need to accept the terms and you need to select your university and proceed. Okay. Do that, and also one more thing. That's it. Just register in that, okay? Register in that Google Generative AI, okay? Accept the terms, choose the university, and proceed as per the options, okay? So do that, everyone. In the meantime, I will upload the collab notebook, okay? I have shared in the chat. I'll drop again. This is the link. It's a Google Generative AI enrollment, okay? It will be helpful for you. Google Generative AI, okay? It's a Google Generative AI. So accept the terms, choose a university, click on next, and record your email. Okay, record your email. Don't forget to check that and fill up your details. Fine. In the meantime, let me just share the notebook. So I have uploaded the notebook also, and this is the drive link. It's better if you enroll in that Google Generative AI. Okay, it's better if you enroll in that. It will be helpful for you. Okay, so if you're having the Skill Boost account or else the Cloud Boost profile account, you can share that URL. Okay. Yeah, I see. It is asking for what are all the things. Let me just share the screen. Okay, I see. It is asking for your full name, email address. Enter your Google Cloud Skill Boost account email address. Ensure that they are not okay. If you have enrolled in this Google Cloud Skill Boost, okay, then you can give your email address. If not, enroll in that. Okay, enroll in that. Just type Google Cloud Skill Boost and click on that link. Okay. If you have not enrolled in it, please sign in. Okay. Please sign in. Click on sign in over here. Continue. Click on continue. Then you will be signed in. Then you can give the name over here. Whatever the email address, you have seen an email address, right? So whatever the email address you're getting, you can type it over here and confirm your email and share your profile URL. Profile URL, just a moment. Let me just sign in. Let me just share this tab first. I'll just sign in, okay? Just give me a minute. Profile URL, right? Just a moment. I'll show you where to find the profile URL. Okay. You'll be getting the profile URL actually. Just a minute. Profile URL. Not in the batches exactly. Export, pause, dashboard. Not in the dashboards also. I see someone is having a query. It's very important, okay? It's in the settings, okay? Fine. Can I find login with your profile and also public profile? And if I click on public profile, so I can share this profile link, okay? I can share the profile link. Once everyone do this, it's like it will be helpful for you, Shiva. It will be very helpful for you in order to understand how exactly Jena is working, okay? How exactly Jena is working, it will be helpful for you. So update that profile link from the particular settings you'll be finding, and then select your mobile number, okay, college name, university, state, and submit the form, okay? Please do that. Video copy the profile link. Just a minute, I will show. Here, here. You just need to click on I consent and also make profile public. Then click on update settings. Okay. After the settings has been updated, you will see this profile link. Okay. You'll see the profile link. Just copy this and paste it over there. Okay. Clear? All you need to do is open that form, checkbox, proceed to next page, and skill boost account it will be asking. So please sign into skill boost. And after signing in, you will see the dashboard. The dashboard will be like this. This is the dashboard, and click here, click on settings. You'll see this. Just you make sure that these two options will be off. Okay, these two options will be off. You need to click on this Credly and also this make public profile, and click on update settings. So with your email the settings has been updated. Then you will see this link. Okay, copy this link, paste it in the form, and fill the other details. That's it, it is done. Okay, got it? No, we'll be sharing the credits. Okay, Ali will be sharing the credits. For now, just sign in and share the profile link. So we'll be sharing the credits with your profile. Okay, fine. Thank you. Roadmap I have already showed you, I think, Harsh, right? In the very first session, I have showed it, right? How will it be helpful? See, the next thing after machine learning is deep learning. After that, you need to understand the transformers architecture. Then the main thing is Gen AI. And even in today's era, if you see, the Gen AI is like from 2023-24 time. In this time period, it's completely AI agents. So you need to understand those topics, right? And Google will be offering free courses also. There will be lab experiments you can do, and to complete those labs, you'll be giving credits. Okay, you'll be given credits, and that credits you'll be getting from the Google. So that is the reason. First, you need to sign in and you need to create your profile. As per your profile link, the credits will be assigned so that you'll be able to do the labs. And by doing the labs, you'll be understanding how the things are working in a real life scenario by using an LLM. Okay, that is why the registration process. Okay, clear, Jayendra? Okay, I hope I have resolved all the queries. This is it for today, guys. So tomorrow there will be a mentoring session. Don't forget to join. Thank you. Thank you, guys. Thank you.